Hello everyone, welcome back to my channel. Today's topic of discussion is Cisco ISE, where we will be talking about what is Cisco ISE, what are its core components, functionalities, and architecture as well. So we will be discussing about how Cisco ISE secures network access through identity, policy, and visibility. We'll identify the evolution from legacy access control solutions to unified ISE platforms. We'll define the Cisco ISE core identity, policy, and access control capabilities. Also, we'll recognize ISE role in enabling identity-based access within zero trust architectures. We'll identify the business and technical drivers that justify deploying ISE. So without much ado, let's get started. So in the introduction of ISE, that is the first thing we need to understand that what is ISE and what are its core capabilities and functions. So to understand this, first we need to understand that modern network landscape is highly distributed. It is omnipresent. Today's hybrid workforce connects from many diverse locations. The extended enterprise incorporates contractors and partners utilizing their own devices and a vast array of Internet of Things and operational technologies like sensors and shadow IT applications that silently integrate into the background. This is where ICE comes in. But before you can justify the investment, you need a clear and concise answer to the first question leadership will ask, that is, what exactly Cisco ICE is. So, to understand Cisco ISE or to define Cisco ISE in simple words, Cisco ISE is a central intelligence for access control. So, Cisco ISE offers centralized network access control, guest access management, profiling, posture assessment, threat mitigation. Therefore, it enhances and improves the security by enforcing policies based on user identity, device type, and location. So, whether an individual connects using a wired, wireless, or VPN connection, Cisco ISE implements a consistent unified access policy. That is what the Cisco ISE does. So, Cisco ISE, the architecture goes like this. You have Cisco ISE solution has unified access policy and it can be connected through wired, wireless, or VPN connections. So Cisco ISE strength is its ability to use contextual information in its decision-making process. Instead of relying only on the usernames and passwords, ISE evaluates a comprehensive set of criteria to determine the appropriate access permissions. Now, the ICE criteria is it is important to know the ICE criteria, which is uses in its evaluation process to better understand how it makes informed access decisions. The criteria set includes factors like who, what, when, where, and how, which can also influence the access decisions. So you can select each tab to look at more information about each factor. These factors give ICE the intelligence to tailor access to each unique situation. Now, the key features of ICE are defining Cisco ICE and benefits of Cisco ICE is what we were covering here. So the key features of ICE is first, in defining ICE, as we have just discussed, Identity Services Engine is a centralized network access control. So ICE is network administration product that enables the creation and enforcement of security policies for the device access to company networks. It provides authentication, authorization, accounting, AAA services. And the benefits from it is that ICE streamlines the network access management, reduces security risk, and ensures the compliance with organizational policies. Thus, it simplifies the administration and improves the overall network security postures. So that is about the basic introduction of what is ICE and what are its key features that it works on. Now, let's take a tale of two connections. So, in modern enterprises, often face diverse network access needs. For example, a contractor in your organization might only require temporary wireless access to a specific set of project files. In contrast to that, a remote employee needs comprehensive VPN access to internal applications and sensitive information to perform their daily tasks. right? So the challenge is how to grant the access for the contractor, the exact access that they require, no more, no less, while ensuring that the untrusted devices possess no risk to the company and providing the employee with full access to all resources from any remote location. So ICE can differentiate between the situations, the different situations, like in this case, the two different situations for the contractor and the employee, and can apply the appropriate network access decisions for each. In ICE transformation, the network from a static all or nothing access model into an intelligent, dynamic system that understands the context and enforces the granular, which is called a least privilege access, and significantly enhance both security and flexibility. Now, about Cisco ISE, it has zero trust security. It has centralized AAA service, contextual visibility, and ecosystem integration. This is what we have just talked about. So, zero trust is identity centric access control, unifying wired wireless VPN context. Centralized AAA is comprehensive service through authentication, authorization, and accounting. All of that management is provided through the centralized AAA service. Contextual visibility provides detailed profiling for the user, device, posture, location for dynamic policy decisions. Ecosystem integration is extensible via PX Grid, that is one of the persona. We will talk about that to share the context with security and network tools. Now, ICE in the smart decision making. There are different features or functions of ICE and the role of ICE in intelligent decision making. Like the role of ICE in intelligent networks is in intelligent networks, ICE act as a critical component ensuring that only authorized users and devices gain access to sensitive resources. And as a result, it safeguards the data used for intelligent decision making. Then, how ICE supports the data security. ICE's granular access control policies protect the data from unauthorized access, preventing breaches that could compromise the integrity of decision making processes. It leverages the contextual data to make smart security decisions. ICE and compliance requirements, it helps the organization meet regulatory compliance requirements by providing detailed logs and reports on network access activities. Accordingly, it ensures accountability and traceability for security incident. Now, this is all we have talked about the roles and functions and key features of ICE here. Now we will talk about the architecture. Now, before that, you have to understand how the evolution and origin of Cisco ISE has happened. So, a critical part of building the business case for ISE is answering the inevitable question from leadership, that is, what were you doing before and why it is no longer good enough? So, before ISE, enterprises once relied on separate Cisco products for network access control. So, Cisco Access Control Server like ACS, Cisco Access Control Server, there was a NAC device, which is a network admission control device. ACS delivered the robust authentication, authorization, accounting services. However, ACS lacked the awareness of device health or posture. This gap was addressed by the NAC device, which focused on evaluating the device compliance and security requirements before allowing the network access. So, it is important to clarify that while NAC is now an acronym for Network Access Control using features such as .1x, the 802.1x, in this specific historical context, it refers to the NAC product which was eventually discontinued and integrated into ICE. So, despite their effectiveness in their own areas, ACS and NAC, they separated the operations, introduced management complexity, and left critical gaps as the enterprise networks became more mobile and diverse. So each solution addressed a part of the network access control challenges, but having to manage and integrate the two products created gaps in complexity. And with that, a transition to Cisco ISE came in. As networks advanced, the enterprises required an integrated solution that combined identity, policy, and compliance all together in one solution. So, ICE delivers a consolidated identity and access management platform. It combined the strong AAA functionalities of ACS and NAC. ACS and the device posture capabilities of NAC. ICE also introduced a new important capability called context awareness. So you can say that ICE is a combination of all the features from ACS, NAC, and additionally the context awareness. And it is much more advanced in its capabilities to collect and interpret the detailed information. And this capability of context awareness collects and interprets the detailed information about who, what, where, when, and how the users and devices access the networks. So that is what the evolution of ICE is. Now, the architecture of ICE and its components, let's talk about that. So, in the architecture, your organization's leadership has approved the business use case, for example, for using Identity Services Engine as core solution for implementing the zero trust service model or security model. The focus now shifts from why you need ICE to how to deploy it. So, as a security engineer, you are now responsible for designing a resilient, scalable, global Cisco ISE architecture, and your challenge is to understand ISE designing its architecture. There are things like personas that we talk about in the architecture, distinguish standalone distributed deployments, strategically placing and scaling the distributed ICE nodes for high availability, low latency. So the success of entire zero trust initiative hinges on the strength and foresight of your foundational design. So what are the different personas? Personas ICE functions are divided into these modules or modular structure called personas that can run on shared or dedicated appliances depending on the scale. So these personas are these PSN, PAN, and MNT and MX grid or PX grid, for example. So PSN is the worker node handling the real-time radius or tech express request, profiling, posture, guest portals, scale horizontally for load. Then PAN policy admin node. This is the centralized configuration interface which handles the policy creation and replication of all the PSNs and supports high availability, active, standby, high availability. MNT is the monitoring and troubleshooting node which collects the logs for reporting and troubleshooting. PX Grid is an additional persona with a license which facilitates the context sharing with security partners like for firewalls, SIEM solutions, and so on. So the core components of ICE are these personas, PSN, MNT, and PAN that we have just discussed. PSN enforces the network access policies, provides authentication, authorization, and accounting services to the network devices, and process the access request and applies appropriate policies based on user and device attributes. MNT, the monitoring and troubleshooting node, collects the logs and generates the reports for monitoring network access activities, troubleshooting security incidents, and valuable insights are provided with it into the network behavior and helps identify the potential threats. Administration node, the PAN node serves as a central management interface for configurations and managing ICE policies, user identities, and network devices, and simplifies the administration and the consistency. The consistent policy enforcements are also provided across the networks through it. Now, ICE deployment can be done as standalone or high availability deployment. Standalone, as the name says, are suitable for small networks because a single ICE appliance handles all functions that we have just discussed. However, it may not provide high availability or scalability for large environments, but it is good for small networks. Then high availability deployment is where the deployments include redundant ICE nodes to ensure continuous operations in event of hardware or software failure. Hence, it minimizes the downtime and maintains network access control service at all times. Then, along with the standalone and high availability deployment, we have also a deployment type called distributed deployment, which offers scalability and redundancy with multiple ICE nodes working together to provide network access control services. Therefore, it ensures high availability and resiliency for mission critical applications. So, these are the three main deployment models of ICE. Now about authentication, authorization, and accounting. The authentication, authorization, and accounting are the key or main functions of the ICE deployment that it provides. So with that, authentication, as the name says, authenticates using methods like username, password, authenticating who you're claiming to be, and identifies your identity and proves your identity. So, based on certificates, username, password, multi factor authentications, the ICE provides authentication. Therefore, organizations can choose the most appropriate method based on their security requirements out of these possible authentication methods. Then, authorization. Authorization is providing the permissions, the rights to access the resources. So, authorization policies define what resources a user or device can access once it is authenticated, and access can be granted based on the user role, device type, location, and other contextual attributes. Accounting is keeping a log, the data of the activities from the user. Could be for the reason of monitoring, for accounting purpose, for auditing. Now, accounting function tracks network usage, including session duration, bandwidth consumption, accessed resources, output, and can be used for billing, reporting, auditing purposes. Now, implementing AAA with ICE, you have to configure authentication policies, you have to define authorization rules and monitoring AAA activities. So, for configuring authentication policies, ICE interface allows easy configuration of authentication policies based on users, groups, device profiles, and you can customize authentication parameters according to your organization needs. Defining authorization rules, you can define precise authorization rules in ICE using contextual data like device type, user location, security posture, ensure users only have access to necessary resources. And monitoring, real-time monitoring of AAA activities in ICE enables rapid detection of suspicious behavior. Create custom reports for auditing or regulatory compliance purposes. Now, about the policy and access control, the ICE provides granular access control of different types: role based, location based, device profiling. Role based access allows the administrator to assign permissions based on user roles, ensuring that users only have access to the resources they need to perform their job functions, and it simplifies the access management and reduce the risk of unauthorized access. Location based access control restricts the access based on physical location of a user, ensuring that the sensitive resources are only accessible from trusted locations, and therefore it helps preventing unauthorized access from untrusted networks. Then there is device profiling, which identifies the type of device connecting to the network, enabling administrators to apply specific policies based on device characteristics. Thus, it enhances the security and ensures compliance within the organization policies. So for policy enforcement, there are different recommendations and solutions for policy enforcement. First is network segmentation. ICE supports network segmentation, which allows the administrations to or administrators to isolate the sensitive resources from rest of the network, and this reduces the impact of security breaches and help comply with regulatory requirements. Guest access management is provided through ICE through management features, allowing the administrators to provide temporary network access to visitors while maintaining security. Thus, it enhances the guest experience and reduces the risk of unauthorized access. Then there is posture assessment, which the ICE performs to ensure that the device connecting to the network meets the security requirement, like having the latest antivirus software, operating system patches, help prevent the malware infections, and reduces the risk of security breaches. Now, integration with network and security ecosystem. Integration capabilities are it can integrate with threat intelligence. The threat intelligence integration feeds to or helps to identify and mitigate security threats in real time. Therefore, it enhances the security and reduces the risk of malware infections. Security information and event management SIEM can be integrated with ISE, and ISE integrates with SIEMs to provide centralized logging and reporting of the security events. It simplifies the security incident management and help comply with the regulatory requirements as well. Then it can also integrate with network device. ICE integrates with the network devices like switches, routers, wireless LAN controllers to ensure that the network access is secured. By enforcing the network access policies accordingly, it ensures consistent policy enforcement across the network. Now, enhancing security through automated threat response, centralized policy management, and streamlined security operations are the key functions of the ICE functions and ICE infrastructure with integration with these additional devices. So, what these integrations and ICE capabilities provides is the additional enhanced security through automated threat response by providing actions such as quarantining an infected device, blocking malicious traffic, reducing the impact of security incident, and minimizing the downtime. Centralized policy management through ICE simplifies the administration, ensures consistent policy enforcement across the network, reduces complexity, and ensure compliance with the organizational policies. Streamlining security operations. It streamlines security operations by providing single pane of glass for managing the network access control policies and simplifies security incident management and reduces the time required to respond to security threats. Now, the real world use cases, some of the common use cases is secure BYOD access, guest network management, zero trust network access. So ICE secures BYOD access by authenticating the user devices and accessing their security posture, enforcing appropriate policies, hence protecting the sensitive data and preventing unauthorized access. Guest network access can be simplified by providing temporary network access to visitors while maintaining security, and zero trust network access also by verifying every user and device before granting access to network resources. Some real world applications are like healthcare, financial services, higher education. There are different other departments as well, which are the real world application use cases. You can read more about it as well. So you will find many applications which are using the ICE and capabilities of ICE. Then for monitoring, reporting, and troubleshooting, like we have seen some of the examples earlier, some integrations which help in providing better monitoring capabilities and centralized management. For real-time monitoring, ICE provides real-time monitoring of network access activities, allowing the administrators to quickly identify and respond to security threats and enhances security and minimizes the downtime. It has event logging, so it logs all network access events, providing a detailed information of the events used for auditing, troubleshooting purposes, and helps comply with regulatory requirements and simplifies the security incident management. Alerting. So ICE generates alerts for suspicious activities, notifying the administrators of potential security threats, enables proactive threat response, and minimizes the impact of security incidents. Reporting and troubleshooting. In ICE, there are custom reports options, troubleshooting tools, integration with SIEM systems to provide the reporting and troubleshooting. Custom reports are used in the ICE to generate the reports for auditing, compliance, performance analysis, and you can extract the information that is relevant to organizational specific audits. Troubleshooting tools are used in ICE. There are different range of tools for troubleshooting network access issues and resolving the security incidents quickly for detailed logs, diagnostics. These are invaluable for identifying the root cause. Integration with SIEM systems. So ICE can seamlessly integrate with SIEM systems to offer centralized logging and reporting of security events and helps in security incident management and ensures compliance with regulations. This is the monitoring, reporting, and troubleshooting dashboard. So you can see the summary of authentication, how many authentication passed, failed, dropped, all events here. You can see the endpoints by profile. You can see radius live log. This is just one example. You can do much more than this that you see on the slide. But monitoring, reporting, troubleshooting is a very important capability of ICE. So it provides visibility, diagnostic, reporting, and system health information with the monitoring, reporting, and troubleshooting capability. Then lastly, the best practices and licensing overview. The best practices for ICE deployment is proper sizing. You have to ensure that ICE appliances are properly sized to handle the network traffic and user load, which prevents the performance bottleneck and ensures smooth user experience. Security hardening is very important. You have to harden ICE appliances by disabling unnecessary services that uh, are by applying security patches, which reduces the attack surface and minimizes the risk of security breaches. There should be regular backups, so a backup of ICE configuration and data regularly should be done to ensure business continuity in the event of any hardware or software failures to minimize the downtime and the risk of data loss. ICE licensing comes in different versions. There are these license type, that is Plus, Base, Apex license. The base license provides the basic network access control features like authentication, authorization, accounting. Therefore, it is suitable for small networks with limited security requirements. Plus license adds some advanced features like device profiling, posture assessment, guest access management, and enhances security and simplifies network administration. Apex license provides the most comprehensive set of features, including threat intelligence and integration, PX grid integration, advanced reporting, which is suitable for large networks with high security requirements. And that is it. So, this was the overview about ICE and how ICE functions, the main functions, architectures, components, and benefits with some additional integrations with ICE. And I hope this will be helpful for you. And thank you for watching.